Assalamualaikum warahmatullahi wabarakatuh. My name is Faris Nur Hakim bin Muhammad and my metric number is 200663. This experiment, which is supposed to be practical for, is about lipid metabolism, which is focusing on determination of lipase activity, and this is its flowchart. So, there are two stages for this experiment. First, we need to create a standard curve, which led us to experiment A, standard curve construction. First of all, oleic acid solution is prepared by adding 1% of volume over volume oleic acid and 99% of volume over volume isooctane, in which the oleic acid is about 0.27 milliliter and the isooctane is about 26.73 milliliter. Then it is stirred until it is emulsified, which basically means it mixes up together by using magnetic bar or homogenizer. As you can see in the bottom, this is a homogenizer and this is the type of magnetic bar used for stirring. Then the stock solution is distributed to 3 vials. This is the vials, but we need 3 of those for each vial at 0, 0.4, 0.8, 1.0, 1.2, 1.4, 1.6 and 2.0 milliliters. So in total we need to have 24 vials, 3 for each volume. The next step, we fill up each vial with isooctane up to 5 milliliter. Then 1 milliliter of copper pyrimidine reagent is added to each of the vial, and each of the vials is then vortexed for 15 seconds to mix it up well. After that, the absorbance of the organic layer formed in the vial is measured at 750 nanometer against an isooctane blank by using this spectrophotometer. We do this after the vials have settled down for half an hour to about 1 hour. After that, the standard curve is constructed by plotting absorbance at 750 nanometer against the amount of oleic acid in 5 milliliter isooctane, as in the second step shown, here. This standard curve is made to ensure precision and accuracy of our measurement, because we cannot simply determine the lipase activity by only knowing its absorbance. We need to have a pure standard solution as a guideline for determining the lipase activity for the next stage. The next stage is the next stage of this experiment, which is about lipase assay. First thing first, the substrate is prepared by homogenizing olive oil, as you can see here, and 50 millimolar of tris hydrochloric acid buffer with pH 7 and the ratio of 1 to 1, which is this, until it is emulsified together. It is emulsified when the color turns to whitish creamy with no double layer. That's the sign of it. Then 2.5 milliliter of substrate emulsion from the first step, 0.02 milliliter of 20 millimolar calcium chloride, 0.005 milliliter of 500 unit per liter of crude lipase sample, and 0.995 milliliter buffer, which is the same as this, is added for each vial, which is prepared in triplicates, meaning 3 of them. Then the mixture is incubated in a water bath at 37 degrees Celsius, and then it is shaken at 150 rpm for 30 minutes. Put it in this water bath. And then the fourth step, the reaction is stopped by adding 1 milliliter of 6 normality hydrochloric acid, and then followed by 5 milliliter of isooctane as an extraction solvent. Then the mixture is then vortexed vigorously for 30 seconds, and then leave it to settle down for about 15 minutes. After that, 4 milliliter of the upper layer of isooctane in the vial is transferred into a new test tube, and 1 milliliter of copper pyridine is added to this test tube. It is then vortexed for 30 seconds and settled down for an hour. Moving on, 1 milliliter of the upper layer solution is taken from the test tube and its absorbance is measured at 715 nanometer by using a spectrophotometer in which isooctane is used as blank as in the first stage of the experiment. If the absorbance reading exceeds more than the standard curve constructed in the first stage of the experiment, just simply repeat the steps by diluting the sample. If everything is fine, lipase activity then can be calculated according to the standard curve made.